Good morning, afternoon, or evening, cats and dogs. Today's video will focus on the lessons 8.2 and 8.3 guided notes on writing and solving two-step equations. In this video, we'll cover problems 1 through 11 in the guided notes, including some independent practice. Don't forget to have the notes in front of you. Make sure you're copying down the guided notes. You can feel free to try some of the questions on your own, and there will be some independent practice built in as well. But you definitely want to make sure you're writing down these example problems and working through them during the video. So let's begin with our example problems. We've already worked with inverse operations with one-step equations. We're now going to talk about two-step equations. So these are going to take two inverse operations or two steps to find our solution. So let's begin with question number 1, which is already done for us. The equation is 5t plus 2 equals 7. So what we want to do is identify what's happening to the variable. We kind of got away from this with our one-step equations after we saw a lot of examples and a lot of practice problems, but we're going to do it for the two-step equations, at least for now. You might be able to get away from doing that as well, either today, tomorrow, or later on this week, or within a few days of seeing some problems with two-step equations. But I want to make sure that we're listing this for this first set of questions that are two-step equations to solve. So in number 1, our equation 5t plus 2 equals 7, the first thing that's happening to the variable is that we're multiplying it by 5. We always want to find our variable and identify what's happening to it. And we're multiplying it by 5. After we multiply our variable t by 5, we're adding by 2. So our inverses are as follows. The inverse of multiplying by 5 is to divide by 5. The inverse of adding by 2, remember we have two possible inverses here, is either to add by -2, which I have written, or you can subtract by 2. Both inverses will work. Remember, for addition and subtraction, there's two possible inverses. Now, when we go to solve, though, we're actually going to work in reverse order, and you'll want to fill in those blanks in your guided notes. So we work from the bottom to the top here. So we undo what was done last to the variable. So the last thing that I did to the variable t was I added 2. That's the first thing that I'm going to undo. So I'm actually going to begin by adding -2. Let me go ahead and highlight that for us. I'm going to begin by adding -2 to both sides. So you can see that I do that on the left and on the right. You also have the option of subtracting by 2. So 2 plus -2 cancels out, but you're still left with 5t. And then on the right-hand side, we have 7 plus -2, which is 5. Notice how once we do our first step, then all we have is a one-step equation left to solve. So again, we're working in reverse order. Now what we're going to do is divide both sides by 5, since that's the inverse of multiplying by 5. We'll show that here. 5 divided by 5 gets you 1t. 5 divided by 5 gets you 1. So your final solution is t equals 1. You can check your solution here. If you grab your calculator, you can do 5 times 1 plus 2, hit equals. You want your calculator to give you 7, and it will. So again, the main things here is list what's happening to the variable in the order in which they're occurring. List your inverse operations and work in reverse order. Mr. Underkoffler likes to call this SADMAP, which is the opposite of PEMDAS. So instead of doing multiplication and division first, and then addition and subtraction, we actually work in reverse order. So addition and subtraction come first, then multiplication and division. That can sometimes fall apart depending on which kind of equations that we have. We will see some equations where you might actually multiply or divide first and then go with adding and subtracting. So I don't want to stress that too much, but it is a way that you would typically do these problems. Add or subtract first, then multiply or divide. So let's take a look at a second example, because practice with solving equations really does help us get better with this. So our second equation is 6u minus 8 equals 28. The first thing that's happening to the variable u is we're multiplying by 6. Then you're subtracting by 8. So our inverses, the inverse of multiply by 6 is to divide by 6. And if you want to write that out using the multiplication and division symbols, that's fine too. It's just a little easier for me to type it. The inverse of subtracting by 8 is to add by 8. So remember that we're going to work in reverse order. So we're actually going to start by adding by 8 on both sides. Let me go ahead and highlight that in green for us. So let's add 8 on both sides of our equation. Plus 8 on the left, plus 8 on the right. And again, I'll highlight that in green. -8 plus 8 cancels out. We want to do 28 plus 8, which is going to get us 36. So we have 6u equals 36. Now we're going to divide both sides by 6. Let's go ahead and do that. 6 divided by 6 gets you 1u, and then 36 divided by 6 gives us a final solution of 6. Keep in mind, a lot of these I'm going to make work out nicely where you get whole numbers or integers as your solution, but it's also possible to get decimals as well. And we'll talk about some of those types of questions. But remember, you can check your solution, do 6 times 6 minus 8, hit equals. You want your calculator to give you 28 to assure your solution is correct. All right, let's move on to number 3. So this one's kind of backwards the way it's written. 21 equals 42 plus 7k. The first thing that's happening to the variable is that we are multiplying by 7. So the variable is k, we're multiplying by 7. The inverse of that is to divide by 7, and we'll do that in a few moments. After we multiply by 7, we're adding by 42, and the inverse of that is to subtract by 42. So remember that we're going to work in reverse order here, meaning that we're going to subtract by 42 first. Try to make that as straight. That's not a straight line, but we'll go with it. So we're going to subtract by 42 on both sides to start. Notice how I line it right up with the other 42, just makes things a little neater and a little nicer. What we want to do is 21 minus 42. You may use your calculators or do it mentally, but I would definitely double check everything. We're going to get negative 21 equals 7k. Just bring that 7k down. Now what we need to do is divide both sides by 7. So we'll do that as our next step. Divide both sides by 7. Negative 21 divided by 7 is negative 3. So our final solution is negative 3 equals k, or k equals negative 3. All right, let's take a look at our next one. Our first one involves division. Again, you might feel comfortable trying some of these on your own. That's fine. Just double check your solutions as you're working through them with this video. So in number 18, the first thing that we're, or number 4, sorry, the first thing that we're doing to g is we're dividing by 3. The inverse of that is to multiply by 3. After we divide g by 3, we are then adding by 6. So the inverse of that is to subtract by 6. We want to work from the bottom to the top, working in reverse order. So the first thing that I want to do is subtract by 6 on both sides. So we show that once on the left and on the right. On the left, 18 minus 6 is going to get us 12. We're still left with g over g divided by 3 on the right-hand side. So the next thing that we need to do is use the inverse operation of multiply by 3. That's the inverse of dividing by 3. Show that once on the left and on the right. These guys will cancel out on the right-hand side, because remember, if we divide by 3, then multiply by 3, we end up getting 1g, or g over 1. We need to do 12 times 3 to get our solution, which of course is 36. All right, let's flip the page and let's go ahead and take a look at question number 5. So number 5, also kind of in reverse order with the variable coming second. We've got negative 7 plus 2x equals 9. The first thing we're doing to the variable x is multiplying by 2. The inverse of that is to divide by 2. After we multiply by 2, we're adding by negative 7. So the inverse of that is either to subtract by negative 7 or add by 7. Let's work in reverse order. So the first thing that we're going to undo is that adding by negative 7. So we're going to add by 7 on both sides. Let's go ahead and do that. Add 7 on the left and on the right. We're going to be left with 2x equals 9 plus 7, which of course is 16. The inverse of multiplying by 2 is to divide by 2, so we're going to divide by 2 on both sides. Pretty easy here with not a lot of negatives in this problem. 2 divided by 2 is 1x. 16 divided by 2 is a solution of 8. All right, we've got a couple more that involve some fractions here, number 6 and 7. Let's take a look at these. I don't have as much space to show the what's happening to the variable in the inverse, but I'm still going to write it for these. You might be getting to the point already where you don't have to write or show that, but I think it's not a bad idea to still continue to do that, at least for today. So in number 6, the first thing that's happening to the variable is we're dividing by 4. The inverse of that is to multiply by 4. And after that, we're adding by 13, and the inverse of that is to subtract by 13. Let's work in reverse order here. So the first thing that we're going to do is subtract by 13 on both sides. So we'll highlight that in green, and we'll subtract 13 on both sides. 13 minus 13 cancels out, leaves you with a over 4. Be careful though, negative 3 minus 13 is not 10 or negative 10, it is negative 16. So I want you to be very careful there. We are now going to do the inverse of dividing by 4, which is to multiply by 4. So let's multiply by 4 on both sides. We're going to do negative 16 times 4, and that's going to get us a solution of negative 64. Again, it's not a bad idea to double check your solution. So if you're going to do this in your calculator, 13 plus negative 64 divided by 4. I would not put it in as a fraction, even though it's written that way. It's just easier to use division to check your solution. All right, let's take a look at number 7. So the first thing that's happening to the variable c is we're dividing by 2. The inverse of that is to multiply by 2. After that, we're adding by negative 3, and the inverse of that is to add by 3. We certainly want to work in reverse order here. So the first thing we're going to do to find our solution is add by 3 on both sides. So let's go ahead and add 3. Let me move this out of the way. Add 3 on the left and on the right. It's going to cancel out on the left to leave you with c over 2. 12 plus 3, of course, is 15. We now want to multiply both sides by 2. So let's go ahead and do that. Whoop, almost gave you the answer there. We're going to be left with c on the left-hand side. And of course, 15 times 2 is 30 for our solution. All right, let's give you a chance to try a couple of these on your own. You can do these any place where you have some space, maybe on the back of these guided notes. You have a little bit of space there, or just any place where you might have some room to put some practice on these things. All right, maybe a sheet of paper. So we've got two questions. Number 1, 6 plus 5x equals negative 29. Number 2, let me slide this up a little bit, is negative 6 equals x over 15 minus 9. Go ahead and pause the video. Give these two questions a try. All right, so hopefully you paused the video and gave both 1 and 2 a try. Let's take a look at number 1 first. The last thing we're doing to x is adding by 6, so let's undo that first. We're going to subtract by 6. We're going to be left with 5x equals negative 29 minus 6 is negative 35. So just double check that. If you accidentally had like 23 or negative 23, you could have missed a negative when you were calculating negative 29 minus 6. Now we need to undo multiplying by 5, so divide both sides by 5. To get a solution of x equals negative 7. All right, number 2. So the last thing that we're doing to the variable x is subtracting by 9. Let's undo that first. Add 9 to both sides. Negative 6 plus 9 is 3, so we have 3 equals x over 15. Multiply both sides by 15 to get our final solution of 45. Hopefully you got at least one of those correct. Keep in mind this is the first time we're seeing this. We'll try to make sure we reinforce these topics as many times as possible. You'll get some additional practice on this as well, both in class and outside of class things to practice. But you should at least feel fairly good about these. Keep in mind with 2 steps, there's a lot more places where you could go wrong. So just be really careful with your work because one little mistake at the beginning could throw off the rest of your solution. All right, so numbers 8 and 9 are very similar. In fact, number 8 is basically the same as question number 9, just with different numbers. Number 8 is done for us. The question is 35 minus x equals 21. So I'm going to say something that's really important here. In all of the questions we've seen thus far, the variable has come before subtraction. So if we go back to some of our other problems, actually this one here, x came before the subtraction. We go back to, I know we have others. We go back to question number 2, the variable came before subtraction, and we didn't see that in any of the other ones. But in all the problems we've seen thus far, the variable came before subtraction. This is the first problem that we're seeing the variable come after subtraction. So I'm going to ask you many times that anytime your variable comes after subtraction, that you rewrite it as an addition problem, that you add the opposite. So I'm actually going to rewrite 35 minus x equals 21 as 35. I'm going to highlight this in purple. 35 plus negative 1x equals 21. I'm also adding a coefficient of negative 1 in front of the x. I'm not really adding it. It's already there. It's just not normally shown. So I'm going to rewrite it as 35 plus negative 1x equals 21. So the mistake I see students do a lot with number 8 is they think they can just add 35 to both sides, and they end up getting a solution of 56. And that's not correct, you'll notice from the rest of the work. What we need to recognize is there's 2 things happening to the variable. We're multiplying by negative 1, and we're adding by 35. The inverse of multiplying by negative 1 is to divide by negative 1, and the inverse of adding by 35 is either to subtract by 35 or add a negative 35. So we work in reverse order, which means we're going to add by negative 35 first. That's going to get rid of this guy. If you add a positive 35, these will not cancel out, which is why we add a negative 35 or subtract 35. So that leaves you with negative 1x equals negative 14. Now what we're going to do is divide both sides by negative 1. Negative 14 divided by negative 1 is positive 14. So let's take a look at question number 9. I would start by rewriting this thing as 19 equals 9 plus negative 1y. So the first thing that's happening to the variable is that, let me just move this box out of the way, we're multiplying by negative 1, then we're adding by 9. So the inverse of multiplying by negative 1 is to divide by negative 1. The inverse of adding by 9 is to subtract by 9. Remember, we want to work in reverse order here. So the first thing we want to do to find our solution is subtract by 9 on both sides. Let's go ahead and do that. If I try to add by 9, these are not going to cancel out. A 9 minus 9 becomes 0, and you're left with negative 1y equals 19 minus 9, which is 10. Now what we want to do is divide both sides by negative 1. So we'll go ahead and divide both sides by negative 1. 10 divided by negative 1 is going to get us negative 10 for our solution. These are really beneficial to check, and since you have a calculator, it's really simple. Just plug in 9 minus negative 10, hit equals. If it doesn't give you 19, you know your solution is wrong, but it will. All right, I have one for you to try independently. So just like before, pause the video, give this question a try, and then we'll take a look at the solution. All right, hopefully you've taken a few moments to try this problem. And hopefully you remember that since the variable comes after subtraction, we are going to add the opposite and rewrite it as 8 plus negative 1t equals negative 10. Now, we are adding 8, so the inverse of that is to subtract 8 from both sides. It's going to cancel out on the left. We're going to be left with negative 1t equals negative 10 minus 8, which is negative 18. Divide both sides by negative 1, you will get t equals positive 18. If you remember, we actually saw problems kind of similar to this without the number in front here. So we had like a negative t equals negative 10, and you had to find a solution for that. We added a 1 in front of your variable. So we did see problems like this, but now we're doing two-step equations. So we're kicking it up a notch. All right, so we have 2 more questions to see and then 1 for you to try independently. Number 10 is also done for you. Number 11 is very similar. So in number 10, the variable comes after subtraction again. This time there is a number besides 1 in front of the variable. It's 2, in fact, a negative 2 once we add the opposite. So I do highly suggest you start off, and I'm going to highlight this in purple, by rewriting this as 14 plus negative 2y equals negative 18. Why? Because the variable comes after subtraction. You may be able to get away with not adding the opposite at some point, but we're not quite there yet. So please do it anytime the variable comes after subtraction. You can do it on any of the other problems as well, but especially when it comes after subtraction. So what's happening to the variable? Let me go ahead and pull this down. We are multiplying by negative 2 and then adding by 14. The inverse of multiplying by negative 2 is to divide by negative 2, and the inverse of adding by 14 is to subtract by 14. So when we work in reverse order, that means we're going to subtract by 14 first on both sides. We get negative 2y equals negative 32. Now divide both sides by negative 2 to get y equals 16. All right, in number 11, I'm going to strongly suggest you rewrite this as 12 plus negative 8r equals 60. What's happening to the variable is we are multiplying by negative 8 and adding by 12. The inverse of multiplying by negative 8 is to divide by negative 8. The inverse of adding by 12 is to subtract by 12. So we want to work in reverse order. That means that we are going to subtract by 12 on both sides first. Let's go ahead and do that. So we'll subtract by 12 on the left and on the right. We end up getting negative 8r equals 48. Then we want to divide both sides by negative 8. So we'll go ahead and do that. On the left-hand side, we're going to be left with 1r, or just r. 48 divided by negative 8 is negative 6. All right, so the last thing in this video is an independent practice problem. Pause the video. Give this one a try. All right, so I really hope, again, you remember that since the variable comes after subtraction, that you started by adding the opposite. We've got a plus 9 here. Let's undo that by subtracting 9 from both sides. That's going to leave us with negative 5j equals negative 15, negative 6 minus 9. Then the inverse of multiplying by -5 is to divide by -5. So divide by -5 on both sides to get j equals +3 for your solution. Keep in mind, I do want to see some more practice on this stuff in class, as well as some independent practice you may be trying on your own as well. So we're not completely done with it, but if you're really, really struggling with this, see me. We can take a look at some additional practice together, either during virtual office hours or during school, those days when you're in person in school. Thanks for listening.